Hi guys, this is Miss Eisencraft. I'm here to talk about special right triangles and how we're going to use them when we develop uh, the unit circle and finding exact values for sine and cosine. So if you remember from Miss Moret's notes, or maybe even from geometry, some special right triangles we've talked about are the 30, 60, 90 triangles. So something we may have discovered, and forgive me if I don't draw to scale too well. Okay, so let's say this is 30 degrees, this is 60, and this is 90. A relationship we know is that the short leg in a 30, 60, 90, if we call this x, the hypotenuse will always be twice as long. So this would be 2x. And then the longer leg would be the short side times the square root of 3. Okay, so that relationship always holds true. That's like the ratio or the relationships of the sides to one another in any 30, 60, 90 degree triangle. Now, when we use it in the unit circle, as you're going to see with Miss Austin, we are going to be looking at these triangles, but the hypotenuse is always going to be 1. So what we're going to talk about is, well, can we keep this relationship true and kind of discover what these sides are if the hypotenuse is in fact 1? So one way to do it, if we kind of just use the principles of algebra working backwards, right? If you take the short side and double it to get the hypotenuse, well, to get from the hypotenuse back to the shorter side, you would cut it in half. So if we double going this way, we're going to take half of it. So half of 1 is 1/2. Now make sure you know this is for a 30, 60, 90. Okay. And then this longer leg will always be the short leg, if you look here, times the square root of 3. So to get this side here, we're going to have to take 1/2, the short leg, times the square root of 3. Let's simplify that. Square root of 3 over 2. Okay. Why this is important is because we will be able to then use that to determine exact cosine and sine values, or the cosine of 30 and the sine of 30, exact values for the cosine and sine of 30. That took me a while to say. So if I ask what the sine of 30 is, this is a 90-degree triangle, so we're going to use the SOHCAHTOA. It's opposite over hypotenuse. So it's 1/2 over 1, or just 1/2. That's a simplified exact answer for the sine of 30 degrees. Okay, the cosine of 30 degrees is adjacent over hypotenuse, so it'd be this side, root 3 over 2 over 1. And as you know, dividing by 1 doesn't do anything, keeps it the same, so it's root 3 over 2. That is an exact answer for the cosine of 30 degrees. Okay, now if we flip the triangle on its side, this is going to be helpful because with Miss Austin's notes, it's going to be helpful to also see it this way. Okay, same thing is true. The short side would be x, the hypotenuse is twice as much, and then the longer leg is x root 3, or short leg times the square root of 3. So if we rewrite this so that we make the hypotenuse equal 1, and it still is 60, 30, 90. Okay, here's the short leg over here now. So this is 1/2. And then the longer leg was the short leg times the square root of 3, which is 1/2 times the square root of 3, which we've already found out was the square root of 3 over 2. So now this will help us find out exact values for the sine of 60 degrees and the cosine of 60 degrees, using this as our reference angle, right? Up here, we were using 30 degrees as our reference angle. So sine of 60 is opposite over hypotenuse, is root 3 over 2. That is the exact simplified answer for sine of 60 degrees. And the cosine of 60 degrees is adjacent over hypotenuse, which is 1/2 over 1. or just 1/2. Hey, look, these are flipped. What? Okay. Finally, the 45, 45, 90. We're only going to have to draw this once because if you flip it, it looks exactly the same. Okay, so if we have 45, 45, 90. Okay, we talked about the relationship would be these two sides are the same. So if this is x, this is also x, and the hypotenuse is x root 2, and that's derived from Pythagorean theorem. Ms. Moret goes over that. Well, okay, so let's change that though. Let's just make the hypotenuse 1 and make sure this relationship still holds true. 45, 45, 90. Okay, if this is 1. All right, so it's usually nicer to start with the shorter side and say, okay, if we have the shorter side, we multiply it by the square root of 2 to get the hypotenuse. So let's go backwards. The opposite of multiplying by the square root of 2 is dividing by the square root of 2. So to get this way, I'm going to get from the hypotenuse to the leg, I'm going to take 1 divided by the square root of 2, which is this length. However, we don't like to have a radical in the denominator. So to get rid of it, we multiply by the square root of 2 over the square root of 2, which is really just multiplying by 1. And then what that does is it gets rid of the radical on the bottom. And we just rewrote it in a nicer way. Okay. And remember, in a 45, 45, 90, whatever this leg is, this leg is. So boom, we have both. Now we can use this as our reference angle. See daisy. Okay, so the sine of 45 is opposite over hypotenuse. So square root of 2 over 2 over 1, which is just. And the cosine of 45 is adjacent over hypotenuse. And the adjacent is actually the same as the opposite. Okay. So let's zoom this out. When Miss Austin is making the unit circle, and when you're making it with her, you're referencing this relationship that was developed maybe in geometry and was reviewed this year, but specifically when the units, when the hypotenuse is 1. So you know Ms. Eisencroft's love for note cards. When you're making the unit circle, it might be nice to have a note card that has these referenced, or at least those notes. So you could have 30, 60, 90, 1. Okay, so in a 30, 60, 90 degree triangle, if the hypotenuse is 1, the short leg is 1/2. Boy, that's not drawn to scale. And this is root 3 over 2. Okay, if you flip it, 60, 30, 90. Hypotenuse is 1. The short side is 1/2. This is root 3 over 2. And finally, if you have a 45, 45, 90, and you make the hypotenuse 1, these two other sides are root 2 over 2, root 2 over 2. And that will be helpful when you're making the unit circle, so you can quickly use our sine and cosine ratios to say, okay, the sine of 30 degrees is opposite of our hypotenuse, 1/2. The cosine of 30 degrees is adjacent over hypotenuse. Okay, using 60 degrees as our reference. The sine of 60 degrees is opposite over hypotenuse. And the cosine of 60 degrees is adjacent over hypotenuse. And again, the hypotenuse is always 1. So you don't need to put over 1 again because it doesn't change it. And then finally, I didn't write my angles in there. The sine of 45 degrees is opposite over hypotenuse. So root 2 over 2, really over 1, but we don't need that. And the cosine of 45 degrees is adjacent over hypotenuse, which is the same. Okay, so have this handy. It takes a while to kind of absorb, and the relationships, making the hypotenuse 1 can be a little bit of be a, be a little bit of a source of confusion instead of having it be 2x or x root 2, but you really just have to kind of reverse the relationship algebraically. All right, good luck.